The term biological diversity was used as early as 1968 by wildlife conservationist Raymond F. Dussman. Later in 1988, entomologist E.O. Wilson used the term biodiversity, and this term has been used since then. Biodiversity refers to the variety of life on Earth. This includes the number of species of plants, animals and microorganisms along with the diversity of genes in these species. Moreover, it embodies the different ecosystems on the planet, for example forests, deserts, coral reefs and wetlands. Biodiversity is the variability among living organisms. This includes diversity within species, between species, and between ecosystems. The variety of biodiversity or the number of species in a given area is referred to as species richness. Normally, variety of life increases with size of area. Biodiversity can be identified at 3 levels. A. Genetic diversity, B. Species diversity, and C. Ecosystem diversity. A. Genetic diversity refers to the total number of genetic characteristics in the genetic makeup of a species. Example, each human being is very different from others. Genetic diversity helps the population to adapt to changes in the environment or adapt to different environments. Domestication of dogs can be taken as a common example. B. Species diversity is the number of different species of plants and animals that are present in a region. A community with more number of species enjoys species richness. Naturally undisturbed forests have greater species richness than reforested areas or plantations. There are 3 types of species. A. Endemic species is one whose habitat is restricted only to a particular area because of which it is often endangered. It differs from indigenous or native, which although it occurs naturally in an area, is also found in other areas. B. Exotic species is any species intentionally or accidentally transported and released by man into an environment outside its original range. These are often the most severe agents of habitat alteration and degradation, and a major cause of the continuing loss of biological diversity throughout the world. C. Cosmopolitan species. It is a species that is found to be distributed over most regions of the Earth. Example, cats, dogs, human beings. The killer whale is considered as the most cosmopolitan species in the world. 183. 1725. C. Ecosystem diversity refers to the variety of life forms in a prescribed ecosystem. Ecosystems may be both terrestrial and aquatic. Distinctive terrestrial ecosystems include forests, grasslands, deserts, etc., while aquatic ecosystems are rivers, lakes, oceans, etc. 3.1 Biodiversity hotspots. Areas that are rich in species diversity are called as hotspots. The hottest spots for species diversity are the tropical rainforests. Tropical rainforests comprise of only 7% of all land on Earth, yet are home to nearly 50% of all the species on Earth. India is among the world's 17 nations that are exceptionally rich in species diversity. The British biologist Norman Myers coined the term biodiversity hotspot in 1988. Hotspots, Earth's biologically richest and most endangered terrestrial ecogens. Conservation International identified 34 biodiversity hotspots in the different countries of the world. They represent just 2.3% of Earth's land surface, but between them they contain around 50% of the world's endemic plant species and 42% of all terrestrial vertebrates. India has 4 biodiversity hotspots: the Western Ghats, the Himalayas, the Indo-Burma region and the Sundaland, includes Nicobar group of islands. Endemism is an ecological word meaning that a plant or animal lives only in a particular geographical location, such as a specific island, habitat type, country or any defined zone. For example, the Asiatic lion of the Gir forest of Gujarat. The Kashmir stag known as Hangul, which is found in the riverine forests of Kashmir Valley and Chamba in Himachal Pradesh. The lion-tailed macaque is India's most threatened monkey, which is endemic to the Western Ghats of South India. The International Union for the Conservation of Nature, IUCN, has identified and classified species based on the nature of their depleting numbers. The IUCN's Red List of Threatened Species, identified in 1964, is the world's most important inventory of the global conservation status of biological species. Species are classified by the IUCN Red List into 9 groups specified through criteria such as rate of decline, population size, area of geographic distribution, and degree of population and distribution fragmentation. Extinct, X. The species has disappeared and no known individuals remaining extinct in the wild, EW, known only to survive in captivity, or as a naturalized population outside its historic range. Critically endangered, CR, species that have drastically dwindled and are at extremely high risk of extinction in the wild. Endangered, N, high risk of extinction in the wild. Times vulnerable, WO, high risk of endangerment in the wild. Near threatened, NT, likely to become endangered in the near future. Least concern, IC, lowest risk widespread and abundant. Conservation dependent, CD, this group has now merged with near threatened. 184. 1725. Data deficient, DD, not enough data to assess the risk of extinction of the species. Not evaluated, NE, species not yet been evaluated against the criteria. In the context of the JACN Red List, threatened, embraces the 3 categories of critically endangered, and vulnerable. According to the IUCN, those species that have dwindled drastically are called as critically endangered and are included as Red List. Species that have disappeared are called as extinct species. 3.2 Major threats to biodiversity. The following are some of the major threats to biodiversity. A. Habitat destruction and degradation. B. Invasive alien species. These can destroy native species. Example, Lantana camara plant in India. See climate change example, bleaching and loss of coral reefs due to global warming, depollution of air, water and soil. Pollution can alter the growth and life of organisms in a great way. Overexploitation of one resource, overexploitation through hunting or poaching, deforestation, etc., can influence the life of all the interdependent species. 3.3 Conservation of biodiversity. Conservation of biodiversity is protection and scientific management of biodiversity so as to maintain it at its optimum level and derive sustainable benefits for the present as well as future generations. It aims to protect species from extinction and their habitats and ecosystems from degradation. The three basic objectives of biodiversity conservation are I. To maintain essential ecological processes and life-supporting systems. B. To preserve the diversity of species. C. To make sustainable utilization of species and ecosystems. There are two types of conservation methods, namely in situ and ex situ conservations. In situ conservation means the conservation of species within their natural habitats. This strategy involves identification of species-rich areas and adopting methods to protect it in the form of national park or wildlife sanctuary or biosphere reserve, etc. In this way, biodiversity can be conserved in their natural habitat from human activities. Ex situ conservation involves maintenance and breeding of endangered plants and animals under partially or wholly controlled conditions in specific areas like zoo, gardens, nurseries, etc. Other examples of ex situ conservation include I. Seed gene bank, 2. Field gene bank, 2. Botanical gardens gene banks. Gene banks are a type of biorepository which preserve genetic materials. Seeds of different genetic strains of commercially important plants can be stored in long periods in seed banks. Gametes of threatened species can be preserved in viable and fertile condition for long periods using 185 cryopreservation techniques. However, it is not economically feasible to conserve all biological wealth and all the ecosystems. The number of species required to be saved from extinction far exceeds the conservation efforts. Biodiversity conservation in situ protected area network, sacred groves, national parks and wildlife sanctuaries, marine biosphere reserves, ex situ sacred plants, home gardens, seed banks, field gene banks and cryopreservation. Terrestrial botanical gardens, arborata, zoological gardens, aquaria. Protected areas. These are biogeographical areas where biological diversity along with natural and cultural resources is protected, maintained and managed through legal measures. Protected areas include national parks, wildlife sanctuaries, community reserves and biosphere reserves. World Conservation Monitoring Center has recognized 37,000 protected areas worldwide. India has about 771 protected areas covering 162099 km2 comprising of national parks, 104, wildlife sanctuaries, 544, biosphere reserves, 18, and several sacred groves. 1 National Parks, NP. It is a natural habitat that is notified by the state government to be constituted as a national park due to its ecological, faunal, floral, geomorphological, or zoological association of importance. No human activity is permitted inside the national park except the activities permitted by the Chief Wildlife Warden of the state under the conditions given in Chapter 4 of the Wildlife Protection Act, WPA, 1972 for the betterment of wildlife and biodiversity and where activities like development, forestry, poaching, hunting, grazing and cultivation are not permitted. 186. 1726. They are large areas of scenic and national beauty maintained for scientific, educational and recreational use. They are not used for commercial extraction of resources. Kaziranga National Park is a protected area for the one-horned rhinoceros in Assam. 2 Wildlife Sanctuaries, WLS. Any area other than the area comprised with any reserve forest or the territorial waters can be notified by the state government to constitute as a sanctuary if such area is of adequate ecological, faunal, floral, geomorphological, natural or zoological significance. This is for the purpose of protecting endangered factual species. Some restricted human activities are allowed inside the sanctuary area, details of which are given in Chapter 4 of the Wildlife Protection Act, WPA, 1972. Ecotourism is permitted, as long as animal life is undisturbed. There are 544 existing wildlife sanctuaries in India covering an area of 118,918 km2, which is 3.62% of the geographical area of the country. National Wildlife Database, 2017. Sanctuaries are tracts of land where wild animals and fauna can take refuge without being hunted or poached. Other activities like collection of forest products, regulated harvesting of timber, private ownership of land are permitted. Periyar Wildlife Sanctuary in Kerala is famous for the Indian tiger and Asiatic elephant. The difference between a sanctuary and a national park lies mainly in the rights of people living inside. In a sanctuary, certain rights are allowed, but in a national park, no rights are allowed for grazing of any livestock. In a wildlife sanctuary, the Chief Wildlife Warden may regulate, control or prohibit certain activities. 3 Conservation reserves and community reserves in India. These terms denote the protected areas of India which typically act as buffer zones between established national parks, wildlife sanctuaries and reserved and protected forests of India. They are called as conservation reserves if they are uninhabited and completely owned by the government of India but used for subsistence by communities. They are called community reserves if a part of the land is privately owned. Sacred groves. A sacred grove or sacred woods are any grove of trees that are of special religious importance to a particular culture. Sacred groves feature in various cultures throughout the world. 3.4 Biosphere reserves. A biosphere reserve is an area of land or water that is protected by law in order to support, sustain and conserve ecosystems. Biosphere Reserve, BR, is an international designation by UNESCO for representative parts of natural and cultural landscapes extending over large area of terrestrial or coastal marine ecosystems or a combination thereof. BRs are designated to deal with the 187. 1726. Conservation of biodiversity, economic and social development and maintenance of associated cultural values. Biosphere reserves are thus special environments for both people and nature and are living examples of how human beings and nature can coexist while respecting each other's needs. The Biosphere Reserve Program is guided by UNESCO's Man and Biosphere (MAB) program, as India is a signatory to the landscape approach supported by MAB program. The scheme called Biosphere Reserve was implemented by the Government of India in 1986. Biosphere reserves of India protect very large areas of natural habitat that are much bigger than national parks or wildlife sanctuaries. Biosphere reserves may cover multiple national parks, sanctuaries and reserves which are contiguous. Example, the Nilgiri Biosphere covers Bandipur National Park, Mudumlai Tiger Reserve, Silent Valley National Park, Nagarhole National Park and Mukurti National Park. Biosphere reserves are traditionally organized into three interrelated zones, known as core area, buffer zone, and transition zone. Times presently, there are 18 notified biosphere reserves in India. Role of communities. Communities are playing a vital role in the conservation and protection of wildlife in India. Example, 1 Sariska Tiger Reserve. In Sariska Tiger Reserve, Rajasthan villagers have fought against mining by citing the Wildlife Protection Act. In many areas, villagers themselves are protecting habitats and explicitly rejecting government involvement. 2 Barodev Dakav Sankural. The inhabitants of 5 villages in the Alwar district of Rajasthan have declared 1,200 hectares of forests as the Barodev Dakav Sankuri, declaring their own set of rules and regulation which do not allow hunting, and are protecting the wildlife against any outside encroachments. 3 Bishnoi villages. In and around Bishnoi villages in Rajasthan, herds of blackbuck, nilgai and peacocks can be seen as an integral part of the community and nobody harms them. 3.5 Biodiversity conservation in India. India is one of the 17 mega biodiverse countries of the world, according to Conservation International. With only 2.4% of the world's land area, 16.7% of the world's human population and 18% of livestock, it contributes about 8% of the known global biodiversity. India has a number of globally important endangered species like Asiatic lion, Asian elephant, one-horned rhinoceros, Gangetic river dolphin, snow leopard, Kashmir stag, dugong, gharial, great Indian bustard, lion-tailed macaque, etc. 1. The following steps have thus been taken to protect and manage the wildlife of the country. 1. The Government of India enacted the Wildlife Protection Act 1972 with the objective of effectively protecting the wildlife of this country and to control poaching, smuggling and illegal trade in wildlife and its derivatives. 188. 1444. 2. The National Board for Wildlife, NBWI, chaired by the Prime Minister of India, provides for policy framework for wildlife conservation in the country. 3. The National Wildlife Action Plan, 2002 to 2016, was adopted in 2002, emphasizing the people's participation and their support for wildlife conservation. 4. The Indian Constitution lays the subject of forests and wildlife in the concurrent list, thus laying the responsibility of wildlife conservation on both the centre and the state. Specialized projects in India. 1. Project Tiger 1973. 2. Operation Crocodile 1975. 3. Project Rhinoceros 1987. 4. Project Snow Leopard 5. Project Elephant 1988. 6. Project Sea Turtle 1999. Specialized projects to save the endangered species of animals. Specialized projects are being implemented with international cooperation, WWF, UNDP, UNEP, IUCN. More recently, the black buck, chinkara, the great Indian bustard and the snow leopard have been given full or partial legal protection against hunting and trade throughout India. 3.6 Important organizations and initiatives. 1. Biodiversity Act, BDA. The Convention on Biological Diversity, CBD, is a United Nations initiative to protect biodiversity and encourage the sustainable use of natural resources. The convention was held in 1992 at the Earth Summit in Brazil. India is a signatory of the CBD. The Biological Diversity Act, 2002 is an act of the Parliament of India for preservation of biological diversity in India, and provides mechanism for equitable sharing of benefits arising out of the use of traditional biological resources and knowledge. The act was enacted to meet the obligations under Convention on Biological Diversity, CBD, to which India is a party. The National Biodiversity Authority, NBA, was established by the central government in 2003 to implement India's Biological Diversity Act, 2002. The NBA is a statutory body and it performs facilitative, regulatory and advisory functions for the Government of India on issues of conservation, sustainable use of biological resources and fair and equitable sharing of benefits arising out of the use of biological resources. The headquarters of the NBA is situated in Chennai. 189. 1445. 2 Sites. The Convention on International Trade in Endangered Species, CITES, of Wild Fauna and Flora, also known as the Washington Convention, is a multilateral treaty to protect endangered plants and animals. It was drafted from a resolution adopted from a meeting of members of the IUCN in 1963 and opened for signature in 1973. It came into force during July 1975. 3. World Wild Fund for Nature, WWF, is an international non-governmental charitable trust founded in 1961, with headquarters at Gland, Vaud, Switzerland. It aims at wilderness preservation and the reduction of human impact on the environment. It was formerly named the World Wildlife Fund. The Living Planet report is being published every 2 years by WWF since 1998. 4. The International Union for Conservation of Nature, IUCN, is an organization working in the field of nature conservation and sustainable use of natural resources. It was established in 1948 and located at Gland, Switzerland. It is involved in data gathering and analysis research, field projects and education on conservation, sustainable development and biodiversity. Red Data Book. Red Data Book or Red List is a catalogue of taxa facing risk of extinction. IUCN, International Union of Conservation of Nature and Natural Resources, which is renamed as WCU World Conservation Union, Morges, Switzerland, maintains the Red Data Book. The concept of Red List was mooted in 1963. 5. The National Tiger Conservation Authority, NTCA, is a statutory body of the ministry. Created under the Wildlife Protection Act, 1972. India holds over half the world's tiger population. 6. Conservation International, CI, is an American non-profit environmental organization founded in 1987 in Virginia. Its goal is to protect nature as a source for food, fresh water, livelihood and a stable climate. CI has helped to support 1,200 protected areas across 77 countries, safeguarding more than 601 million hectares of marine and coastal areas. Conservation International, CI, adopted Maya's concept of hotspots and it made an extensive global study of hotspots in 1999. According to CI, to qualify as a hotspot, a region must meet 2 strict criteria. 1. It must contain at least 1,500 species of endemic plants, and 2. It must have lost at least 70% of its original habitat. 190. 1445. 7. Convention on Biological Diversity, CBD, the United Nations Convention on Biological Diversity, known as CBD in short, was signed by TA and 172 other nations on 29 December 1993. The CBD was an attempt to establish international program for conserving and using the world's biological resources. This historical treaty recognizes the sovereign right of nation over their genetic resources and considers appropriate access to genetic resources. The treaty also takes into account the fair and equitable sharing of benefits arising from the use of genetic resources. Biodiversity is necessary for our existence as well as valuable in its own right. This is because it provides the fundamental building blocks for the goods and services that provide us with a healthy environment. Biodiversity includes fundamental things to our health like fresh water, clean air and food products, as well as many other products like timber, medicine and fiber. Biodiversity also includes various other important things and services such as cultural, recreational and spiritual nourishment that play an important role in maintaining our personal life and social life. It is therefore the duty of every citizen to conserve this valuable life on Earth, the most precious gift we can pass on to the future generations. 3.7 Agrobiodiversity. Agrobiodiversity is the variety and variability of bioresources in a region at a point of time. The diversity includes plants, animals, soil microorganisms and of course the human being. This is directly or indirectly related to food and agriculture, crop and animal husbandry, forestry and fisheries. India is one of the most diverse countries in the world. It occupies only about 2.4% the world's land area, and yet it harbors 7 to 8% all recorded species, including about 45,000 species of plants and 91,000 species of animals. The country has the primary, secondary or regional centers of diversity of at least 167 crop species and 320 wild relatives of crops. Agrobiodiversity role. Besides its ecological and intrinsic value, biodiversity has a considerable socio-economic and monetary value as well. Such values attached to biodiversity can be classified as 1. Productive use value. It is the value assigned to products that are commercially harvested for exchange in formal market. Such products are fuel wood, timber, fish, animal skin, musk fodder, fruits, cereals and medicinal plants. 2. Consumptive use value. The value of biological resources that is reflected on natural products that are consumed directly. These goods do not enter the normal channel of trade. A significant number of non-timber forest product, minor forest products, as soft broom grass and cane fall under this category. 191. 1446. 3. Indirect values. The values are related to intangible benefits with the functions of ecosystems which do not normally appear in national accounting systems. Maintenance of ecological balance and prevention of soil erosion are examples of such indirect values. Major concerns for agrobiodiversity. 1. Genetic erosion and loss. Genetic resources which provide food security are in distress due to several factors, especially the anthropogenic. As per the National Biodiversity Action Plan, 41% of India's forest cover is at different levels of degradation. Traditional varieties of a wide range of crops with specifically adapted gene complexes to local environments such as rice, small millets, pseudo-cereals etc. have disappeared from several agroecosystems. It is believed that around 5,000 landraces of rice collected from northeast region of India are no more under cultivation in that region. 2. Genetic pollution. The release of transgenic plants at commercial scale has evoked a number of biosafety issues in relation to biodiversity, human and animal health. The genetic resources have to be protected from the contamination of transgens. The movement of unwanted genes into the environment may pose more of a management dilemma than unwanted chemicals, as such alleles have the opportunity to multiply themselves. The impacts and costs of invasive species include crop losses, rangeland value decline, water resource depletion, livestock disease, genetic contamination and management and eradication costs. Many introduced pests such as insects, seed-borne virus and fungi, and invasive species such as Prosopis juliflora, Acacia auriculiformis, Lantana camara and alien fish species in aquatic ecosystem have led to significant changes in native ecosystems. 3. Impact of global climate change. Agricultural biodiversity is at risk from climate change, IPCC, 2007. Species and communities at particular and possibly critical risk include those with limited climatic ranges, limited dispersal ability and those with specialized habitat requirements. Besides, some indigenous pests that were earlier not causing much damage are emerging as serious pests such as foliar blight in wheat, necrosis in sunflower, bract mosaic in banana, sheath blight in maize and paddy, pyrella in sugarcane, etc. Increase in physiological reactions at high temperatures will elevate heat loads of animals resulting into a decline in productivity of meat, wool, milk and draught power. Temperature increase is likely to cause a rise in animal diseases that are spread by insects and vectors. Incidences of mastitis and foot diseases will increase due to the rise in temperature and humidity. Besides, introduction of naturally occurring or genetically modified pests diseases into weaponry, livestock, crops and medicine is a possibility, which if not adequately anticipated and controlled, may threaten entire populations and ecosystems. 192. 1446. Sustainable use of agrobiodiversity. Genetic diversity is important for 3 main reasons. First, it helps in providing stability of farming systems through a range of inter- and intra-specific characteristics. In conventional or mixed farming systems broadly, losses suffered by one variety, if any, can be compensated for by continuity or gains in another. Secondly, it provides insurance against changing environmental conditions that may be anticipated for the future. For example, resistance to new diseases or adaptability to changed climatic conditions can be searched from within the existing agrobiodiversity. Thirdly, it embodies characteristics that are potentially valuable, but not yet exploited. The genes found in the largely untapped wealth of undomesticated plants can provide a basis for enhanced food availability in future by their use in improvement of crop varieties. A significant example of appropriate use of existing agrobiodiversity may be provided in the extensive use of Oryza nivra, an Indian germplasm, for developing grass-resistant virus-resistant varieties of rice. This disease during the 1970s had devastated rice fields from India to Indonesia, endangering the world's single most important food crop. Likewise, there are several examples of crop epidemics that occurred as a result of narrow genetic base in the existing cultivars' landraces, which required incorporation of resistance endurance gene in the new varieties of these crops from respective gene pools. The genetic diversity also helps crops to withstand changes in environment, climate and agroecosystems besides the threats from pests and diseases. In each of the diverse ecosystems, biological diversity is at the root of the complex ecological balance, and its availability for plant improvement work is vital for all research and development efforts. Overall, the agrobiodiversity exists primarily at the intraspecies level and is important in respect of the genetic variability therein. New varieties of traditional crops continue to be developed through traditional and modern tools. However, no new major crop species has been domesticated from the wild in recent times. Future increases in agricultural production are likely to continue to be derived from the development of new plant varieties with desirable characteristics and from the more effective use of commercial inputs. However, the new varieties will have to be well adapted to harsher environmental conditions, such as stress or excess of temperatures, moisture and salts, in order to ensure overall growth in agricultural productivity and production. Also, the sustainability of agricultural systems rather than their short-term productivity will have to be ensured, besides mitigating the other negative side effects of modern agriculture. The initiatives for on-farm conservation of landraces and crops of local importance have been recently undertaken in Western Himalayan region and Bastar area of Chhattisgarh. 193. 1447. The establishment of sanctuaries in Tura Range in Garo Hills of Meghalaya for conservation of rich native diversity of wild citrus and musa species, and for rhododendron and orchids in Sikkim is also helping in situ conservation of economically important species. Agrobiodiversity builds the foundation of sustainable agricultural development and is an essential natural resource to ensure current and future food and nutrition security. 194. 1447. 4. Environmental issues. Environmental issues are the problems and harmful effects created by humans' unmindful activity and overutilization of valuable resources obtained from the nature, environment. Drastic increase in population resulted in demand for more productivity of food materials, fibers, fuels, which led to many environmental issues in agriculture, land use modifications resulting in loss of biodiversity, land degradation, reduction in freshwater availability, and also resulting in man-made global warming by greenhouse gases, even altering climatic conditions. 4.1 Greenhouse effect and global warming. Greenhouse effect is a process by which radiant heat from the sun is captured by gases in the atmosphere that increase the temperature of the earth ultimately. The gases that capture heat are called greenhouse gases, which include carbon dioxide, CO2, methane, CH, nitrous oxide, NO, and a variety of manufactured chemicals like chlorofluorocarbon, CFC. Increase in greenhouse gases lead to irreversible changes in major ecosystems and climate patterns. For example, coral ecosystem is affected by increase in temperature, especially coral bleaching observed in Gulf of Mannar, Tamil Nadu. Human activities lead to produce the greenhouse effect by burning fossil fuels, which releases CO and CH. Way of agriculture and animal husbandry practices. Electrical gadgets like refrigerator and air conditioners release chlorofluorocarbons. The fertilizers used in agriculture which release NO. Times the emissions from automobiles. The increase in mean global temperature, highest in 4,000 years, due to increased concentration of greenhouse gases is called global warming. One of the reasons for this is overpopulation, which creates growing need for food, fiber and fuel, and considered to be the major cause of global warming. Effects of global warming. Rise in global temperature which causes sea levels to rise as polar ice caps and glaciers begin to melt, causing submergence of many coastal cities in many parts of the world. There will be a drastic change in weather patterns, bringing more floods or droughts in some areas. Biological diversity may get modified, some species ranges get redefined. Tropics and subtropics may face the problem of decreased food production. Sources of greenhouse gases emission, natural and anthropogenic. 1. CO2, carbon dioxide, coal-based power plants, by the burning of fossil fuels for electricity generation. Combustion of fuels. In the engines of automobiles, commercial vehicles and airplanes contribute the most of global warming. 195. 1448. Agricultural practices like stubble burning result in the emission of CO2 natural from organic matter, volcanoes, warm oceans and sediments too. Methane is 20 times as effective as CO at trapping heat in the atmosphere. Its sources are attributed paddy cultivation, cattle rearing, bacteria in water bodies, fossil fuel production, ocean non-wetland soils and forest wildfires. 3. N20, nitrous oxide. It is naturally produced in oceans from biological sources of soil and water due to microbial actions and rainforests. Man-made sources include nylon and nitric acid production, use of fertilizers in agriculture, manures, cars with catalytic converter and burning of organic matter. Global warming effects on plants. Times low agricultural productivity in tropics, frequent heat waves, weeds, pests, fungi need warmer temperature. Increase of vectors and epidemics, strong storms and intense flood damage, water crisis and decreased irrigation. Change in flowering seasons and pollinators. Times change in species distributional ranges. Species extinction strategies to deal with global warming: increasing the vegetation cover, grow more trees, reducing the use of fossil fuels and greenhouse gases, developing alternate renewable sources of energy, minimizing uses of nitrogenous fertilizers, and aerosols. 4.2. Ozone depletion. Ozone layer is a region of Earth's stratosphere that absorbs most of the sun's ultraviolet radiation. The ozone layer is also called as the ozone shield, and it acts as a protective shield, cutting the ultraviolet radiation emitted by the sun. Just above the atmosphere there are two layers, namely troposphere, the lower layer, and stratosphere, the upper layer. The ozone layer of the troposphere is called bad ozone, and the ozone layer of stratosphere is known as good ozone because this layer acts as a shield for absorbing the UV radiations coming from the sun, which is harmful for living organisms, causing DNA damage. The thickness of the ozone column of air from the ground to the top of the atmosphere is measured in terms of Dobson units. The ozone shield is being damaged by chemicals released on the Earth's surface, notably the chlorofluorocarbons widely used in refrigeration, aerosols, chemicals used as cleaners in many industries. The decline in the thickness of the ozone layer over restricted area is called ozone hole. 196. 1449. Ozone depletion in the stratosphere results in more UV radiations, especially UVB radiation, shortwaves. UVB radiation destroys biomolecules, skin aging, and damages living tissues. UVC is the most damaging type of UV radiation, but it is completely filtered by the atmosphere full layer. UVA contribute 95% of UV radiation, which causes tanning, burning of skin, and enhancing skin cancer. Hence, the uniform ozone layer is critical for the well-being of life on Earth. The Vienna Convention was agreed upon at the Vienna Conference of 1985 but entered into force in 1988, provided the frameworks necessary to create regulative measures in the form of the Montreal Protocol. The international treaty called the Montreal Protocol, 1987, was held in Canada on substances that deplete ozone layer, and the main goal of it is gradually eliminating the production and consumption of ozone depleting substances and to limit their damage on the Earth's ozone layer. Effects of ozone depletion. The main ozone depletion effects are: increases the incidence of cataract, throat and lung irritation, and aggravation of asthma, emphysema, skin cancer, and diminishing the functioning of immune system in human beings. Juvenile mortality of animals. Times increased incidence of mutations. In plants, photosynthetic chemicals will be affected and therefore photosynthesis will be inhibited. Decreased photosynthesis will result in increased atmospheric CO2, resulting in global warming and also shortage of food, leading to food crisis. Increase in temperature changes the climate and rainfall pattern, which may result in flood, drought, sea water rise, imbalance in ecosystems affecting flora and fauna. 4.3. Pollution. Pollution is any undesirable change in the physical, chemical, and biological characteristics of the environment due to natural causes and human activities. The agents which cause pollution are called pollutants. Pollution is classified according to the types of environment that is affected. They are mainly air, water, and soil pollution. Classification of pollutants. In terms of ecosystem, pollutants can be classified into two basic groups, non-degradable and agradable. Based on the time taken to break down into their ingredients, degradable pollutants are classified as rapidly degradable, non-persistent, and slowly degradable, persistent. Rapidly degradable or non-persistent pollutants, these can be broken down by natural processes. Domestic sewage and vegetable waste are examples of such pollutants. Slowly degradable or persistent pollutants, these are pollutants that remain in the environment for many years in an unchanged condition and take decades or longer to degrade, as he case of DDT. Kanagraj, Faculty, Agriculture. 197. 1449. C. Non-degradable pollutants, these cannot be degraded by natural processes. Once they are released into the environment, they are difficult to be eliminated and continue to accumulate. Biomagnification. Toxic elements like lead, mercury, cadmium, chromium and nickel are such common pollutants. 1. Air pollution. Earth is surrounded by a gaseous envelope which is called atmosphere. The gaseous blanket of the atmosphere acts as a thermal insulator and regulates the temperature of the Earth by selectively absorbing the UV rays of solar radiation. The adverse effects of pollution include depletion of ozone by chlorofluorocarbons or CFCs used as refrigerants and global warming by elevated CO2, industries, deforestation, and partial combustion. The alterations or changes in the composition of the Earth's atmosphere by natural or human activities, anthropogenic factors, are referred as air pollution. Pollutants include the abundant presence of solid, liquid or gaseous substances produced by human or natural activity. The nature and concentration of a pollutant determines the severity of detrimental effects on organisms and human health. Along with atmospheric factors, humidity, precipitation, wind, air currents, altitude, prevailing at a place and time, its effects can be far-reaching and catastrophic. Air pollutants can be discharge of dusts or particulate matter, PM 2.510. Discharge of gases, SO2, number 2 CO. Carbon monoxide, CO, is produced mainly due to incomplete combustion of fossil fuels. Automobiles are major causes of co-pollution in large cities and towns. Automobile exhausts, fumes from factories, emission from power plants, forest fires and burning of firewood contribute to co-pollution. With rapid urbanization, major amount of carbon dioxide and sulfur dioxide, SO2, is released in the atmosphere from automobiles, aeroplanes, power plants and other human activities that involving the burning of fossil fuels, coal, oil etc. CO2 is the main pollutant that is leading to global warming. Nitrogen oxides are also major air pollutants. Fossil fuel combustion and automobiles exhausts are the source of nitrogen oxides. Sulfur dioxide and nitrogen oxides are the major causes of acid rain. Particulate matters are tiny particles of solid matter suspended in a gas or liquid. Combustion of fossil fuels, fly ash produced in thermal power plants, forest fires, asbestos mining units, cement factories are the main sources of particulate matter pollution. Sources. The main sources of air pollution are times transport sources: cars, buses, airplanes, trucks, trains. 198. 1450. Stationary sources: power plants, incinerators, oil refineries, industrial facilities, and factories. Area sources: agricultural, wood stubble burning, fireplaces. Natural sources: wind-blown dust, wildfires, volcanoes. Effects of air pollution affects all organisms as they depend on the atmosphere for respiration. Causes irritation in the throat, nose, lungs and eyes. It causes breathing problems and aggravates existing health conditions such as emphysema and asthma. Contaminated air reduces the body's defense mechanism and decreases the body's capacity to fight other infections in the respiratory system. Frequent exposure to polluted air increases the risk of cardiovascular diseases. Breathing air that is filled with fine particulate matter can induce hardening of the arteries, triggering cardiac arrhythmia or even a heart attack. People who exercise outdoors can sometimes be susceptible to adverse effects of air pollution because it involves deeper and faster breathing. Hence it is advisable to walk or jog in the mornings in places with ample tree cover. Gas leaks can be lethal or affect the quality of air in the affected area. CO in the atmosphere interferes with CO2 transport since hemoglobin has greater affinity for carbon monoxide. At low concentration it causes headache and blurred vision. In higher concentration, it can lead to coma and death. Other notable effects of air pollution. 1. Smog is a type of air pollution caused by tiny particles in the air. The word comes from a mixture of the words smoke and fog. Today, smog generally refers to photochemical smog, which is created when sunlight reacts with nitrogen oxides and volatile organic compounds found in fossil fuel emissions from automobiles, factories, and power plants. These reactions create ground-level ozone and particulate matter, reducing visibility. Smog can make breathing more difficult, especially for people with asthma. Smog also affects plants and animals. It damages crops as well as causes health problems in pets, farm animals and human beings. Smog has also been known to cause corrosive damage to buildings and vehicles. Peroxyacetyl nitrate, PAN, is a secondary pollutant present in photochemical smog. It is thermally unstable and decomposes into peroxyethanol radicals and nitrogen dioxide gas, causing eye irritation. 2. Global warming, increase in the concentrations of greenhouse gases such as CO2, methane nitrous oxide, CFCs, and ozone causes greenhouse effect, warming of the earth, resulting in sea level rise, submerging of islands and seashores of various parts of the world. 3. Ozone depletion, thinning of the stratospheric ozone layer is known as ozone depletion. 199. 1450. Such depletion causes the bone how resulting in poor screening of the harmful UV rays and increase in incidences of skin cancer. Some of the common agents that deplete non are CFCS4. Acid rain, a form of precipitation that contains ACC components such as sulfuric acid or nebic acid. It damages trees, crops and harms marine animals, coral reefs, and induces control of air pollution. Certain measures help to remove pollutants, reduce their presence or prevent their entry into the atmosphere. Trees are the best remedy for urban particulate and gaseous pollution. Forests act as carbon sinks and lungs of the planet. Catalytic converters in vehicles help to reduce polluting gases drastically. Diesel exhaust filters in automobiles cuts particulates. Electrostatic precipitators reduce release of industrial pollutants. Cost-effective air pollution treatment systems like indoor plants and high-performance biofilters can improve indoor air quality. Legal protection. The Air, Prevention and Control of Pollution Act was enacted in 1981 and amended in 1987 for the prevention, control and abatement of air pollution in India. Traffic emissions standards. The government has decided to enforce Bharat Stage 6 norms from 2020. The Green Bench and the National Green Tribunal, NGT, give judicial safeguard to environmental protection. 2. Water pollution. Water pollution occurs when there is a change in the chemical, physical or biological quality of water that has harmful effects on living organisms that consume it or live in it. Water pollution adversely affects water bodies due to the large amounts of natural or man-made materials let into it. When it becomes unfit for its intended use, water is considered polluted. Sources of water pollution. Even though water bodies or sources can be polluted by natural causes, water pollution is usually caused by human activities. There are three main types of sources: point sources, non-point sources, leaks and spills. Point sources, discharge of pollutants at specific locations through pipelines or sewers into the water body. Factory effluents, sewage, underground mines, oil wells, oil tankers and agriculture are common point sources. Non-point sources, sources that cannot be traced to a single site of discharge like acid rain, dumping of the plastics in water bodies, agriculture chemical runoff are common examples. 1451. Leaks and spills. This occurs mostly due to ship collision, offshore oil rigs, or leakages and discharges into sea. Sources of water pollution can also be classified in three ways. They are municipal wastes, industrial wastes and agricultural wastes. 1. Municipal wastewater is from homes and commercial establishments. 2. Industrial discharge, effluents, may contain varieties of compounds such as heavy metals, cadmium, chromium, lead, and inorganic chemicals containing wastewater sometimes in toxic concentrations. These discharges can affect temperatures of the water bodies as well as dissolved oxygen level. 3. Agricultural wastes include fertilizer and pesticide runoff from agricultural fields, food processing waste, tree and sawdust from logging operations and bacteria from sewage or livestock operations. Water pollutants reach water bodies like rivers, streams and the marine system by precipitation, runoff and the groundwater by seepage or percolation. Effect of water pollution on ecosystems. 1. Destruction of ecosystems. Ecosystems, especially aquatic systems, can be severely affected or destroyed by water pollution. Water pollutants affect existing niches and habitats and the survival of organisms. Soil fertility is affected and the system becomes uninhabitable. 2. Disruption of food chains. Water pollution disrupts the natural food chains as well as food webs. Pollutants such as lead and cadmium are taken up by primary consumers where they can be lethal or get stored. Later, when these animals are consumed by secondary consumers, the food chain can get disrupted at any trophic level or result in enhanced concentration of these pollutants. Biomagnification. Hot water from industries when released into the water bodies affects aquatic density and diversity. Effect of water pollution on organisms. 1. Water pollution can be lethal to aquatic organisms and others that depend on these water bodies. Accidental oil spills from tanker ships can cause substantial environmental damage. Oil spreads on the water surface, prevents the entry of light and oxygen into the water. This increases bod and cod, resulting in mass death of organisms and degradation of water quality. It also clogs fish gills and the feathers of aquatic birds. 2. Humans and other organisms can get affected by diseases such as hepatitis and typhoid by consuming contaminated water and food. Excess of fluoride in drinking water causes fluorosis. In many poor nations, outbreak of waterborne diseases and epidemics are a result of contaminated water and poor or absence of water treatment processes. 3. Water pollution can cause eutrophication due to nutrient enrichment. This causes algal blooms which affect the quality of water bodies. Fig 13.3. Red tides, if occur, can be lethal to aquatic organisms. 201. 1451. EMI. And control measures. 1. Right to clean water is a fundamental right under the Indian Constitution. 2. Water, Prevention and Control of Pollution Act, 1974, Sections 17 to 40 prohibit the pollution of a stream or well by disposal of polluting matter. 3. The Central State Pollution Control Boards have the power to advise the central state government on various matters concerned with the prevention and control of pollution of water. 4. The Ministry of Environment, Forest and Climate Change, MoEFCC, is the nodal agency of the central government for the planning, promotion, coordination and for overseeing the implementation of India's environmental and forestry policies and programs. Prevention, regulate or control of pollutant, discharge at the point of generation. Wastewater can be pre-treated by scientific methods before discharge to municipal treatment sources. Setting up of sewage treatment plants, STP, and effluent treatment plants, ETP. Regulate or restrict the use of synthetic fertilizers and pesticides. Public awareness and people's involvement is essential. Biomagnification food chains are components of all ecosystems. Producers and consumers form trophic levels in a chain through which energy flow is carried out by the process of eating and being eaten. Usage, storage and transformation of food and biomolecules by metabolism are a normal process. Degradation or breakdown is an essential part of any food chain and hence all naturally occurring substances are degradable. Biomagnification of DDT. When non-degradable substances enter the food chain, they do not get metabolized or broken down or expelled and instead get transferred up the trophic levels of the food chain. During this process, they show an increase in concentration which is referred to as biomagnification. This results in increased toxicity and may even be lethal. This phenomenon is well established for mercury and DDT. Eutrophication. When runoff from land containing nutrients reaches water bodies like lakes, it results in dense growth of plant life. This phenomenon is called eutrophication. Natural aging of lakes also leads to nutrient enrichment of its water. In a lake, the water is cold and clear, oligotrophic stage, supporting little life. With time, streams draining into the lake introduce nutrients such as nitrates and phosphates, which encourage the growth of aquatic organisms. Aquatic plants and animal life grow rapidly, and organic remains begin to be deposited on the lake bottom, mesotrophic stage. 202. SGK 1451, EMI and Control measures. 1. Right to clean water is a fundamental right under the Indian Constitution. 2. Water, Prevention and Control of Pollution, Act, 1974, Sections 17 to 40 prohibit the pollution of a stream or well by disposal of polluting matter. 3. The Central State Pollution Control Boards have the power to advise the central state government on various matters concerned with the prevention and control of pollution of water. 4. The Ministry of Environment, Forest and Climate Change, MoEFCC, is the nodal agency of the central government for the planning, promotion, coordination and for overseeing the implementation of India's environmental and forestry policies and programs. Prevention, regulate or control of pollutant, discharge at the point of generation. Wastewater can be pre-treated by scientific methods before discharge to municipal treatment sources. Setting up of sewage treatment plants, STP, and effluent treatment plants, ETP. Regulate or restrict the use of synthetic fertilizers and pesticides. Public awareness and people's involvement is essential. Biomagnification food chains are components of all ecosystems. Producers and consumers form trophic levels in a chain through which energy flow is carried out by the process of eating and being eaten. Usage, storage and transformation of food and biomolecules by metabolism are a normal process. Degradation or breakdown is an essential part of any food chain and hence all naturally occurring substances are degradable. Biomagnification of DDT. When non-degradable substances enter the food chain, they do not get metabolized or broken down or expelled and instead get transferred up the trophic levels of the food chain. During this process, they show an increase in concentration which is referred to as biomagnification. This results in increased toxicity and may even be lethal. This phenomenon is well established for mercury and DDT. Eutrophication. When runoff from land containing nutrients reaches water bodies like lakes, it results in dense growth of plant life. This phenomenon is called eutrophication. Natural aging of lakes also leads to nutrient enrichment of its water. In a lake, the water is cold and clear, oligotrophic stage, supporting little life. With time, streams draining into the lake introduce nutrients such as nitrates and phosphates, which encourage the growth of aquatic organisms. Aquatic plants and animal life grow rapidly, and organic remains begin to be deposited on the lake bottom, mesotrophic stage. 202. SGK 1452. Crop residue burning. Dubbing of paddy rubble owing the harvest and 20th October of the year to prepare the land for sowing of wheat by November 25th in Punjab, Haryana and western Uttar Pradesh, leading to smog over large area of Indo-Gangetic Plains. Oxygen in a highly concentrated form over Delhi NCR is another example of pollution. Crop residue burning is one among the many sources of air pollution. Burning of farm waste causes severe pollution of land and water at both local as well as regional scale. This also adversely affects the nutrient budget in the soil. Straw carbon, nitrogen and sulfur are completely burnt and lost to the atmosphere. In the process of burning, it results in the emission of smoke which, if added to the gases present in the air like methane, nitrogen oxide and ammonia, can cause severe atmospheric pollution. These gaseous emissions can result in health risk, aggravating asthma, chronic bronchitis and decreased lung function. Burning of crop residue also contributes indirectly to the increased ozone pollution. It has adverse consequences on the quality of soil. When the crop residue is burnt, the existing minerals present in the soil get destroyed, which adversely hampers the cultivation of the next crop. 4. Climate change and sustainability. The Earth's climate has changed throughout history. In the last 650,000 years, there have been several cycles of glacial and warm periods, each lasting thousands or millions of years. Most of these climate changes are attributed to very small variations in Earth's orbit that changes the amount of solar energy our planet receives. It is understood that at present the Earth's climate is getting warmer, which is referred to as global warming. Earth's temperature has gone up about 1 degree Fahrenheit in the last 100 years. This is a very small change, but small changes in Earth's temperature can have big effects. Some effects are already happening, such as melting of glaciers, rise in the level of oceans, prolonged droughts, excessive rain and floods, etc. Reasons for climate change. Burning fossil fuels emits gases into the atmosphere. Burning fossil fuel to provide energy, coupled with the effects of major transportation and deforestation, causes a rapid increase in global temperatures. This can change the climate of a place. Effects of climate change. Scientists had predicted in the past that the result from global climate change are now occurring: loss of sea ice, accelerated sea level rise and longer, more intense heat waves. Temperatures will continue to rise. Experts agree that greenhouse gases which trap heat and prevent it from leaving the Earth's atmosphere are mostly responsible for the temperature spike too. Frost-free season and growing season will lengthen. It could actually have detrimental effects on the crops we grow. Warmer weather helps pests survive longer, which can destroy crops. Rising temperatures are also expected to contribute to a shift in areas which are agriculturally most productive and the crops that grow there. 204-1452. Changes in precipitation patterns. The contrast between wet and dry areas will increase globally. In other words, the wet areas will get wetter and the dry areas will get drier. 3 More droughts and heat waves. With rising temperatures and shifting rainfall patterns, heat waves and droughts are increasing in frequency and intensity. 4. Sea level rise. Scientists have determined that global sea level has been steadily rising since 1900 at a rate of at least 0.1 to 0.25 cm per year. Sea level can rise by 2 different mechanisms with respect to climate change. 5. Arctic likely to become ice-free. The Arctic Ocean is expected to become essentially ice-free in summer before mid-century. Response to climate change. There are 2 main responses to climate change. 1. Mitigation, which addressed the root causes of climate change by reducing greenhouse gas emissions. 2. Adaptation seeks to lower the risks posed by the consequences of climatic changes. Both approaches will be necessary to deal with the global changes that have already been set in motion. Mitigation measures. 1. Cleaner alternative energy sources. One important way to fight climate change is to reduce our reliance on and usage of fossil fuels, and depend on alternative renewable and greener sources of energy such as wind energy, solar energy, water or hydropower, biomass, and geothermal energy. 2. Energy saving tips. We can adopt energy saving tips by investing in more expensive energy saving appliances like the compact fluorescent light, CFL, bulbs, air conditioners, refrigerators, etc. Switching off our electrical appliances when not in use. 3. Green driving tips. The best strategy to reduce toxic gas emissions is definitely to reduce the use of automobiles. Use public transport, carpooling, use of electricity-powered cars or two-wheelers can be an alternative. 4. Reduce, reuse, recycle practices. Reducing, reusing and recycling helps us conserve resources and energy, and reduce pollution and greenhouse gas emissions produced thereby. 5. Reforestation. The cleanest and most efficient remover of carbon dioxide from our atmosphere actually is nothing but green plants and trees. The rate at which we are cutting down our trees and forests to make way for human developments has greatly reduced the Earth's ability to remove carbon dioxide from the atmosphere. 6. Organic farming soils are an important sink for atmospheric carbon dioxide. Nevertheless, deforestation making way for conventional agriculture is increasingly depleting this sink. Sustainable and organic agriculture helps to counteract climate change by restoring soil organ. 205. 1453. Matter content as well as reduce soil erosion and improve soil physical structure. Organic farming uses natural fertilizers and helps maintain crop yields. Mitigation strategies. These are the actions to reduce greenhouse gas emission and sequestration or storage of carbon in the short term, and developmental choices that will be lead to low emission in the long term. Reducing emissions of carbon dioxide, methane and nitrous oxide. Reduction in the emission of greenhouse gases by changing the practice of transplanting rice with the direct seeded rice, aerobic rice, which require less water, and due to aerobic conditions the emission of CH4 and CO2 gases will be less. Sequestering carbon. Sequestering atmospheric carbon is very important, as without reducing the atmospheric level of carbon, it is not possible to mitigate the climate change. The switch over to carbon sequestering practices is recommended. C. Resource conservation technologies. Any method, material or tool which enhances the input use efficiency, crop productivity and farm gate income is termed as resource conservation technology. It includes crop establishment system, zero tillage, minimum tillage or reduced tillage, etc., water management, adoption of laser land leveler technique, and nutrient management, use of SPAD or SSNM or slow release fertilizers, etc. D. Enriching soil organic matter. By applying FYM, compost or by practicing organic farming we can improve the soil organic matter, which can help in improvement of soil health. Carbon capture and storage, CCS. Carbon capture and storage is a technology of capturing carbon dioxide and injects it deep into the underground rocks into a depth of 1 kilometer or more, and it is an approach to mitigate global warming by capturing CO2 from large point sources such as industries and power plants and subsequently storing it instead of releasing it into the atmosphere. Various safe sites have been selected for permanent storage in various deep geological formations, liquid storage in the ocean and solid storage by reduction of CO2 with metal oxide to produce stable carbonates. It is also known as geological sequestration, which involves injecting CO2 directly into the underground geological formations, such as declining oil fields, gas fields, saline aquifers, and unminable coal have been suggested as storage sites. Carbon sequestration. Carbon sequestration is the process of capturing and storing CO2 which reduces the amount of CO2 in the atmosphere with the goal of reducing global climate change. Carbon sequestration occurs naturally by plants and in ocean. Terrestrial sequestration is typically accomplished through forest and soil conservation practices that enhance the storage carbon. As an example, microalgae such as species of Chlorella, Cnidosmus, Crococcus and Chlamydomonas are used globally for CO2 sequestration. Trees like Eugenia caryophyllata. 206. 1453. Tecomastans cinnamomorum have high capacity and noted to sequester carbon. Macroalgae and marine grasses and mangroves are also have ability to mitigate carbon dioxide. Sea grasses and mangroves of estuarine and coastal systems are the most efficient in carbon sequestration. Hence these ecosystems are called as blue carbon ecosystems. They are not properly utilized and maintained all over the world, although they have rich biosources potential. A carbon sink is a natural or artificial reservoir that accumulates and stores carbon for an indefinite period. The process by which carbon sinks remove carbon dioxide from the atmosphere is known as carbon sequestration. The main natural carbon sinks are plants, the ocean and soil. Carbon footprint, CFP. Every human activity leaves a mark just like our footprint. This carbon footprint is the total amount of greenhouse gases produced by human activities such as agriculture, industries, deforestation, waste disposal, burning fossil fuels directly or indirectly. It can be measured for an individual, family, organization like industries, state level or national level. It is usually estimated and expressed in equivalent tons of CO2 per year. The burning of fossil fuels releases CO2 and other greenhouse gases. In turn, these emissions trap solar energy and thus increase the global temperature, resulting in ice melting, submerging of low-lying areas and imbalance in nature like cyclones, tsunamis and extreme weather conditions. Biochar. Biochar is another long-term method to store carbon. To increase plants' ability to store more carbon, plants are partly burned such as crop waste, waste woods to become carbon-rich slow decomposing substances of material called biochar. It is a kind of charcoal used as a soil amendment. Biochar is a stable solid, rich in carbon and can endure in soil for thousands of years. Like most charcoal, biochar is made from biomass via pyrolysis, heating biomass in low oxygen environment, which arrests wood from complete burning. Biochar thus has the potential to help mitigate climate change via carbon sequestration. Independently, biochar when added to soil can increase soil fertility of acidic soils, increase agricultural productivity, and provide protection against some foliar and soil-borne diseases. It is a good method of preventing waste woods and logs getting decayed. Instead, we can convert them into biochar, thus converting them to carbon storage material. Impact of climate change in Indian agriculture. Rainfall, no long-term trend noted. However, regional variations seen, increased summer rainfall and less number of rainy days. Temperature, about 0.6 degrees Celsius rise in surface temperature during 100 years. Projected to increase 3.5 to 5 degrees Celsius by 2100. 207. 1454. Carbon dioxide, increasing at the rate of 1.9 ppm per year and expected to reach 550 ppm by 2050 and 700 ppm by 2100. Extreme events. Increased frequency of heat wave, cold wave droughts and floods observed during last decade. Rising sea level, rise of 2.5 mm years since 1950. Glaciers, rapid melting of the glacier in the Himalayas. Rainfall distribution, shift in PE rainfall distribution also noticed in some parts of country. Expected impact of climate change on agriculture. Over the past few decades, the gaseous composition of the atmosphere has undergone a significant change, mainly through increased industrial emissions, fossil fuel combustion, widespread deforestation and burning of biomass, as well as changes in land use and land management practices. These anthropogenic activities have resulted in an increase of greenhouse gases, i.e., carbon dioxide, CO2, methane, CH4, and nitrous oxide, N20. These GHGs trap outgoing infrared radiations from the Earth's surface and thus raise temperature. Crop. Due to increase in temperature, crop may require more water. Yield may be reduced in cereal crops, especially in rabi, i.e. wheat. Increase in ambient CO2 is beneficial since this leads to increased photosynthesis in several crops, especially those with CB mechanism of photosynthesis such as wheat and rice. Cold waves and frost events could decrease in future due to global warming, and this would lead to a decreased probability of yield loss associated with frost damage in northern India in crops such as mustard and vegetables. Despite this, the yield of major cereal crops likely to be reduced due to decrease in rainfall. Reduction in yields in the rain-fed areas due to changes in rainfall pattern during monsoon season and increased crop water demand. Due to increase in rainfall, pests like bollworm, red hairy caterpillar and leaf spot diseases may increase. 208. 1454. Due to increase in temperature, sucking pests such as mites and leaf miner M due to variation in rainfall and temperature, pest and diseases of crops to be altered because of more enhanced pathogen and vector development, rapid pathogen transmission and increased host susceptibility. Sometimes a minor pest might become a major pest. Agricultural biodiversity is also threatened by decreased rainfall and increases temperature, sea level rise and increased frequency and severity of drought, cyclone and flood. Quality of farm products such as fruits, vegetables, tea, coffee, aromatic and medicinal plants may be affected. Water. Demand for irrigation to increase with increased temperature and higher amount of evapotranspiration. This may result in lowering of groundwater table at some places. The melting of glaciers in the Himalayas will increase water availability in the Ganga, Brahmaputra and their tributaries in the short run, but in the long run the availability of water will decrease considerably. A significant increase in runoff is projected in the rainy season, however, may not be very beneficial unless storage infrastructure could be vastly expanded. This extra water in the rainy season, on the other hand, may lead to increase in frequency and duration of floods. The water balance in different parts of India will be disturbed and the quality of groundwater along coastal track will be more affected due to intrusion of sea water. Soil, organic matter content, which is already quite low in Indian soil, would become even lower. Quality of soil organic matter may be affected. The residues of crops under elevated CO2 concentration will have higher C/N ratio, and this may reduce their rate of decomposition and nutrient supply. Increase in soil temperature may reduce nitrogen availability due to volatilization and denitrification. Change in rainfall volume and frequency as well as wind may alter the severity, frequency and extent of soil erosion. 209. 1454. Rise in sea level may lead to salt water entry in the coastal lands, turning them less suitable for conventional agriculture. Livestock affect feed production and nutrition of livestock. Increased temperature would increase lignification of plant tissues, reducing the digestibility. Increased water scarcity would also decrease the food and fodder production. Major impacts on vector-borne diseases through expansion of vector populations during rainy years, leading to large outbreaks of diseases. Increase water, shelter, and energy requirement of livestock for meeting projected milk demands. Climate change is likely to aggravate heat stress in dairy animals, adversely affecting their reproductive performance. Fishery increased sea and river water temperature is likely to affect fish breeding, migration and harvest. Impacts of increased temperature and tropical cyclonic activity would affect capture, production and marketing costs of the marine fish. Global initiatives on climate change. 1. Anticipate, absorb, reshape, A2R. The UN Climate Resilience Initiative, Anticipate, Absorb, Reshape, A2R, is a global multi-stakeholder initiative that strengthens climate resilience for vulnerable countries and people. It forges linkages between climate change adaptation, disaster risk reduction, and sustainable development, in order to accelerate the implementation of the Paris Agreement and the Sendai Framework for Disaster Risk Reduction for delivering on the Sustainable Development Goals. 2. Climate and Clean Air Coalition. The Climate and Clean Air Coalition is a voluntary partnership of governments, intergovernmental organizations, businesses, scientific institutions and civil society organizations committed to improving air quality and protecting the climate through actions to reduce short-lived climate pollutants. 3. Global Environment Facility. 210. 1455. Shankar IAS Academ. The Global Environment Facility was established on the eve of the 1992 Rio Earth Summit to help tackle our planet's most pressing environmental problems. Today, the GEF is an international partnership of 183 countries, international institutions, civil society organizations and the private sector that addresses global environmental issues. 4. Green Climate Fund. The fund is a unique global platform to respond to climate change by investing in low-emission and climate-resilient development. GCF was established to limit or reduce greenhouse gas (GHG) emissions in developing countries, and to help vulnerable societies adapt to the unavoidable impacts of climate change. 5. United Nations Framework Convention on Climate Change, UNFC, one of the 3 Rio Conventions. The UNFC's ultimate objective is to achieve the stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous interference with the climate system. The Paris Agreement under the UNFC was adopted in December 2015 and entered into force on November 2016. This agreement was the outcome of the negotiations launched in 2011 at the 17th Conference of the Parties in Durban to develop a legal instrument applicable to all parties to cut greenhouse gases, GHG, emissions and to be implemented from 2020. 6. The Adaptation Fund. The Adaptation Fund finances climate change adaptation and resilience activities in developing countries that are vulnerable to the adverse effects of climate change and are parties to the Kyoto Protocol. 7. Climate Technology Center and Network. The CTCN is the operational arm of the UNFC technology mechanism, hosted by the UN Environment Programme and the UN Industrial Development Organization, UNIDO. The center promotes the accelerated transfer of environmentally sound technologies for low-carbon and climate-resilient development at the request of developing countries. 8. The Paris Agreement on Climate Change. The historic Paris Agreement provides an opportunity for countries to strengthen the global response to the threat of climate change by keeping a global temperature rise this century well. 211. Below 2 degrees Celsius and to pursue efforts to limit the temperature increase even further to 15 degrees Celsius. It entered into force on 4 November 2016. India's progress in combating climate change. 1. National Action Plan on Climate Change, NAPC. Launched in 2008, India's National Action Plan on Climate Change, NAPC, identifies a number of measures that simultaneously advance the country's development and climate change-related objectives of adaptation and mitigation. The implementation of the NAPC is designed to take place through 8 national missions, which form the core of the National Action Plan and incorporate multi-pronged, long-term and integrated strategies for achieving India's key goals in the context of climate change. Jawaharlal Nehru National Solar Mission, National Mission for Enhanced Energy Efficiency, National Mission on Sustainable Habitat, National Water Mission, National Mission for Sustainable Agriculture, National Mission for Sustaining the Himalayan Ecosystem, National Mission for a Green India, National Mission on Strategic Knowledge for Climate Change. 2. National Clean Energy Fund. The Government of India created the National Clean Energy Fund, NCEF, in 2010 for the purpose of financing and promoting clean energy initiatives and funding research in the area of clean energy in the country. The corpus of the fund is built by levying a cess of 100 rupees per ton of coal produced domestically or imported. 212. 3. State Action Plan on Climate Change. In 2008, the Government of India launched the National Action Plan on Climate Change, NAPC, establishing 8 priority missions. For the realization of these proposed actions at the subnational level, in August 2009 the Prime Minister of India called upon star governments to prepare their own state action plan on climate change, SAPCO consistent with strategies in the NAPCO 4. NABD, Progressing Adaptation Action. India's National Bank for Agriculture and Rural Development, NABD, has been accredited as a national implementing entity, NI, for India for the Adaptation Fund created under the United Nations Framework Convention on Climate Change, UNF. At present, NABD is the only NI in the Asia-Pacific region. 5. Auto Fuel Vision and Policy 2025. In December 2012, the Government of India constituted an expert committee for drafting the Auto Fuel Vision and Policy 2025 for the country. 6. Indian Network for Climate Change Assessment. To enhance knowledge about the impacts of climate change at the national and subnational level, Indian Network for Climate Change Assessment, INCA, was launched on 14 October 2009. 7. Bilateral Cooperation on Environment and Clean Technology. India has been successful in establishing bilateral relations with several countries on key areas of development and growth. In 2007, India and Canada signed a joint statement on India-Canada Forum on Environment Cooperation. National Innovations on Climate Resilient Agriculture, NICRA. National Innovations on Climate Resilient Agriculture, NICRA, is a network project of the Indian Council of Agricultural Research, ICAR, launched in February 2011. The project aims to enhance resilience of Indian agriculture to climate change and climate vulnerability through strategic research and technology demonstration. The research on 213. 1456. 3. State Action Plan on Climate Change. In 2008, the Government of India launched the National Action Plan on Climate Change, NAPC, establishing 8 priority missions. For the realization of these proposed actions at the subnational level, in August 2009 the Prime Minister of India called upon star governments to prepare their own state action plan on climate change, SAPCO consistent with strategies in the NAPCO. 4. NABD, Progressing Adaptation Actions. India's National Bank for Agriculture and Rural Development, NABD, has been accredited as a national implementing entity, NI, for India for the Adaptation Fund created under the United Nations Framework Convention on Climate Change, UNF. At present, NABD is the only NI in the Asia-Pacific region. 5. Auto Fuel Vision and Policy 2025. In December 2012, the Government of India constituted an expert committee for drafting the Auto Fuel Vision and Policy 2025 for the country. 6. Indian Network for Climate Change Assessment. To enhance knowledge about the impacts of climate change at the national and subnational level, Indian Network for Climate Change Assessment, INCA, was launched on 14 October 2009. 7. Bilateral Cooperation on Environment and Clean Technology. India has been successful in establishing bilateral relations with several countries on key areas of development and growth. In 2007, India and Canada signed a joint statement on India-Canada Forum on Environment Cooperation. National Innovations on Climate Resilient Agriculture, NICRA. National Innovations on Climate Resilient Agriculture, NICRA, is a network project of the Indian Council of Agricultural Research, ICAR, launched in February 2011. The project aims to enhance resilience of Indian agriculture to climate change and climate vulnerability through strategic research and technology demonstration. The research on 213-1457. 2. Technology demonstration on farmers' fields to cope with current climate variability. 3. Sponsored and competitive research grants to fill critical research gaps. 4. Capacity building of different stakeholders. Key features. Critical assessment of different crops zones in the country for vulnerability to climatic stresses and extreme events, in particular, intra-seasonal variability of rainfall. Installation of the state-of-the-art equipment like flux towers for measurement of greenhouse gases in large field areas to understand the impact of management practices and contribute data on emissions as national responsibility. Rapid and large-scale screening of crop germplasm including wild relatives for drought and heat tolerance through phenomics platforms for quick identification of promising lines and early development and release of heat drought-tolerant varieties. Comprehensive field evaluation of new and emerging approaches of paddy cultivation like aerobic rice and shri for their contribution to reduce the GHG emissions and water saving. Special attention to livestock and fishery sectors including aquaculture which have not received enough attention in climate change research in the past. In particular, the documentation of adaptive traits in indigenous breeds is the most useful step. Thorough understanding of crop-pest-pathogen relationship and emergence of new biotypes due to climate change. Simultaneous upscaling of the outputs both through KVKS and the National Mission on Sustainable Agriculture for wider adoption by the farmers. Measures taken agriculture sector to combat climate change. Various measures have been undertaken to enhance food security, while at the same time there have been focused interventions aimed at diversifying Indian agriculture into non-food grain crops and promoting animal husbandry and fishing. The National Food Security Mission aims at increasing cereal and pulses production by 20 million tons by concentrating on those areas which have the greatest potential for increase in yields with the given technology. The National Horticulture Mission has also been expanded. Rashtriya Krishi Vikas Yojana, RKVY, is a focused program that provides additional financial resource to the state governments to finance agriculture development programs. The strategy is also aided by the MNREG Act, by 215. 1458. Building projects that help in the larger objectives of enhancing agricultural productivity because priority is also being given to projects aimed at water conservation. The Ministry of Agriculture Government of India has adopted a mega project called the National Initiative on Climate Resilient Agriculture, NICRA, in 2011 with four main modules: natural resource management, improving soil health, improving crop production and livestock to make the farmers self-reliant for adaptation under changing climate. National Mission for Sustainable Agriculture, NMSA, was derived from the Sustainable Agriculture Mission component of the NAPC. Improved crop seed, nutrient management, soil health management and the on-farm water management components of the NMSA have the potential to reduce the GHG emissions from cropland through the management of water use and fertilizer application to the soil. Overview of the mitigation actions initiated in the agriculture sector. 1. Expansion of area under horticulture systems. The horticulture sector encompasses a wide range of crops such as fruits, vegetables, flowers, spices and nuts. The fruit crops produce relatively higher biomass and are retained in the field for a relatively longer period, and thus sequester carbon both above and below ground. Government of India has launched National Horticulture Mission, NHM, in June 2005 with an objective to raise horticulture production, improve nutritional security and enhance income to farmers. The area under horticulture grew about 3.8% and production rose by 7.4% per annum during the last decade. 2. System of rice intensification, SRI, cultivation. System of rice intensification is a method of rice cultivation consisting of transplanting 8 to 12-day-old seedlings at wider spacing of 25 cm x 25 cm. Unlike the traditional transplanted paddy system, standing water is not maintained in SRI system and the field is maintained at saturation. Due to alternate wetting and drying cycles, the methane emissions get reduced significantly. As a part of the National Food Security Mission, NEFM, SRI method of cultivation is being promoted in 199 districts which have been selected for paddy interventions in NEFM. The extent of coverage of area with SRI system is given in table 3.6. 3. Crop diversification from transplanted paddy to other food crops. Under this initiative, 500 crores were sanctioned for diverting the paddy area to other crops due to the depleting groundwater resources and decline in soil quality due to continuous paddy cultivation in 3 states, Punjab, Haryana and Uttar Pradesh. This will indirectly reduce methane emission too. 216. kanagraj.bioscience@gmail.co. 1459. Shankar IAS Akkad. 4. Improvement in energy efficiency through micro-irrigation. Micro-irrigation systems, MIS, deliver water directly to the root zone of crops resulting better water use efficiency. Loss of water during application and conveyance gets reduced in irrigation systems resulting in savings of water and reduced time for irrigation. MIS cutter hours in delivering water and thus reduces the consumption of electricity. Replacing flood of irrigation with micro-irrigation systems reduces electricity consumption required for water. This eventually reduces greenhouse gas emissions through reduced consumption of power or fossil fuel-based captive power. Micro-irrigation systems also enhance productivity quality of agriculture product. Area covered under efficient irrigation systems is given pump. Major International Environmental Conventions 1972, UN Conference on Human Environment, Stockholm, Sweden 1972, UN Environment Programme, UNEP, Stockholm, Sweden 1987, Montreal Protocol, Vienna 1989, Intergovernmental Panel on Climate Change, Geneva, Switzerland. 1992, Earth Summit, Rio de Janeiro. Agenda 21, otherwise called Rio Conference, Brazil 1997, Kyoto Protocol, Japan 2002, World Summit on Sustainable Development, Johannesburg, South Africa 2003, World Climate Change Conference, Moscow, Russia 2012, UN Conference on Sustainable Development, Rio de Janeiro 2015, UN Sustainable Development Summit, New York 2016, Montreal Protocol Amendment at Kigali, Rwanda 2017, the COP23 Climate Change Summit in Bonn, Germany 2018, UN Climate Change Conference, Katowice, Poland. 217-1738. 5. Remote sensing and GIS. Remote sensing is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance from the targeted area. It is a tool used in conservation practices by giving exact picture and data on identification of even a single tree to large area of vegetation and wildlife for classification of land use patterns and studies. Identification of biodiversity-rich or less areas for futuristic works on conservation and maintenance of various species including commercial crop, medicinal plants and threatened plants. Specific uses. Helps predicting favorable climate, for the study of spreading of disease and controlling it. Mapping of forest fire and species distribution. Tracking the patterns of urban area development and the changes in farmland or forests over several years. Times mapping ocean bottom and its resources. Applications of remote sensing. 1. Agriculture. The satellites have ability to image individual fields, regions and countries on a frequent revisit cycle. Customers can receive field-based information including crop identification, crop area determination and crop condition monitoring, health and viability. Satellite data are employed in precision agriculture to manage and monitor farming practices at different levels. 2. Forest management. The forest fire, sudden deforestation, encroachment of forest land are recent challenges to the ecologist. It can be easily identified and curbed with the help of remote sensing satellite pictures. 3. Geology. Various fields. Remote sensing techniques used in geology are lithological mapping, structural mapping, geomorphological mapping, mineral exploration, hydrocarbon exploration, sedimentation mapping and monitoring, geohazard mapping. 4. Oceanography satellite remote sensing plays an important role in coastal zone management. It allows us to locate and regularly monitor various aspects such as bathymetry, the measurement of the depth of water in water bodies, chlorophyll content, suspended sediment concentration, etc. 218. 1738. 5. Cartography. Remote sensing aids in extensive surveys that are made from high altitudes to show the urban development, rural development, mountain areas, deserts, etc., which help the cartographers. High-resolution satellite cameras located at altitudes of several hundred kilometers can record details as small as a few meters on the surface of the Earth. 16. Meteorology. The radar system is basically used to collect the weather data. It collects meteorological data from unmanned land ocean-based data collection platforms and serves as a communication satellite for rapid exchange of meteorological data among centers and for rapid dissemination of weather forecasts, warnings, etc., to user agencies. 7. Topography. Topography specifically involves the recording of relief or terrain, the three-dimensional quality of the surface, and the identification of specific landforms. Topographic maps usually portray both natural and man-made features. They show and name works of nature including mountains, valleys, plains, lakes, rivers, and vegetation. They also identify the principal works of man, such as roads, boundaries, transmission lines, and major buildings. 8. Urban planning. These information systems also offer interpretation of physical, spatial, data with other socio-economic data, and thereby providing an important linkage in the total planning process and making it more effective and meaningful. Digitization of planning base maps has facilitated updating of base maps wherever changes have taken place in terms of land development, etc. Superimposition of any two digital maps which are on two different scales is feasible. Applications of remote sensing in agriculture. 1. Monitoring of vegetation cover. The science of remote sensing play a vital role in the area of crop classification, crop acreage estimation and yield assessment. Many research experiments were done using aerial photographs and digital image processing techniques. But the field of remote sensing helps in reducing the amount of field data to be collected and improves the higher precision of estimates. The most commonly used index to assess the vegetation condition is the Normalized Difference Vegetation Index. The Normalized Difference Vegetation Index, NDVI, Vegetation Condition Index, VCI, Leaf Area Index, LAC, General Yield Unified Reference Index, GURI, and Temperature Crop Index, TCI, are all examples of indices that have been used for mapping and monitoring drought and assessment of vegetation health and productivity. 2. Crop condition assessment. Remote sensing can play an important role in agriculture by providing timely spectral information which can be used for assessing the biophysical indicators of plant health, the physiological. 219. 1738. Changes that occur in a plant due to stress may change the spectral reflectance emission characteristics, resulting in the detection of stress. Amenable to remote sensing techniques. Crop monitoring at regular intervals of crop growth is necessary to take appropriate measures and also to know the probable loss of production due to any stress factor. 3. Nutrient and water status. The most important fields where we can opt for application of remote sensing and GIS through the application of precision farming are nutrient and water stress management. Detecting nutrient stresses by using remote sensing and GIS helps us in site-specific nutrient management through which we can reduce the cost of cultivation as well as increase the fertilizer use efficiency for the crops. In semi-arid and arid regions, judicious use of water can be made possible through the application of precision farming technologies. For example, drip irrigation coupled with information from remotely sensed data such as canopy air temperature difference can be used to increase the water use efficiency by reducing the runoff and percolation losses. 4. Crop evapotranspiration. Remote sensing is playing a major role in the water management for agricultural system. The decline in the productivity of crops is due to irregularities in rainfall, increase in the temperature rate, etc., which causes a decrease in the soil moisture. Drought is a situation which can be defined as a long-term average condition of the balance between precipitation and evapotranspiration in a particular area, which also depends on the timely onset of monsoon as well as its potency. In turn, vegetation indices such as CWSI, Crop Water Stress Index, SCENT, Surface Temperature, WDI, Water Deficit Index, and Street Stress Index describe the relationship existing between water stress and thermal characteristics of plants. 5. Weed identification and management. Precision weed management technique helps in carrying out the better weed management practices. Remote sensing coupled with precision agriculture is a promising technology in nowadays. Though, ground surveying methods for mapping site-specific information about weeds are very time-consuming and labor-intensive. However, image-based remote sensing has potential applications in weed detection for site-specific weed management. Based on the difference in the spectral reflectance properties between weeds and crop, remote sensing technology provides a mean for identifying the weeds in the crop stand and further helps in the development of weed maps in the field so that site-specific and need-based herbicide can be applied for the management of weeds. 6. Pest and disease infestation. Remote sensing has become an essential tool for monitoring and quantifying crop stress due to biotic and abiotic factors. Remote sensing methodologies need to be perfected for identification of insect breeding grounds for developing strategies to prevent their spread and taking effective. 220. 1739. Control measures. The remote sensing approach in assessing and monitoring insect defoliation has been used to relate differences in spectral responses to chlorosis, yellowing of leaves and foliage reduction over a given time period, assuming that these differences can be correlated, classified and interpreted. Landsat 5 trademark image can be used to accurately detect and quantify disease for site-specific wheat streak mosaic disease management in the wheat crop. 7. Crop yield and production forecasting. Remote sensing has been used to forecast crop yields primarily based upon statistical empirical relationships between yield and vegetation indices. The information on production of crops before the harvest is important for national food policy planning. Reliable crop yield is an important component of crop production forecasting purpose. By using IRSP3 VFS, wide field sensor, and IRS1C WIFES and list3 which have a good periodicity, it may be possible to construct growth profiles and retrieve yield-related parameters at region level. 8. Precision agriculture. Remote sensing technology is a key component of precision farming and is being used by an increasing number of scientists, engineers and large-scale crop growers. The main aim of precision farming is reduced cost of cultivation, improved control and improved resource use efficiency with the help of information received by the sensors fitted in the farm machineries. Variable rate technology, VRT, is the most advanced component of precision farming. Sensors are mounted on the moving farm machineries containing a computer which provides input recommendation maps and thereby controls the application of inputs based on the information received from GPS receiver, NRC, 1997. The advantage of precision farming is the acquisition of information on crops at temporal frequency and spatial resolution required for making management decisions. Remote sensing is a no doubt valuable tool for providing such information. Multispectral remote sensing used for site-specific nitrogen fertilizer management. 9. Atmospheric dynamics. Among the other applications through remote sensing, meteorological satellites are playing an important role in the forecasting of weather conditions. Meteorological satellites are designed to measure the atmospheric temperature, wind, moisture, and cloud cover. The variations in the canopy temperature could indicate the areas of adequate and inadequate water in the field condition. The canopy temperature variability, CTV, is used in irrigation management, and canopy air temperature difference, CAT, might be used as an indicator of crop water stress. 221. 1739. Why? Future prospects. Remote sensing is highly useful in assessing various abiotic and biotic stresses in different crop and also very useful in detecting and management of various crop issues even at small farm holdings. To effectively utilize the information on crops for improvement of economy, there is a need to develop state or district level information system based on available information on various crops derived from remote sensing and GIS approaches. The governments can use remote sensing data in order to make important decisions about the policies they will adopt or how to tackle national issues regarding agriculture. A new and non-traditional remote sensing application involves the implanting of nanochips in plant and seed tissue that can be used in near real time to monitor crop. Clearly, these and other new approaches will reinforce the importance of remote sensing in future analysis of agricultural sciences. Geographic Information System. GIS is a computer system for capturing, storing, checking and displaying data related to positions on Earth's surface. Also to manipulate, analyze, manage and present spatial or geographic data. Importance of GIS. Times environmental impact assessment. Disaster management. Zoning of landslide hazard, determination of land cover and land use, estimation of flood damage, management of natural resources, times soil mapping, times wetland mapping, times irrigation management and identification of volcanic hazard, times vegetation studies and mapping of threatened and endemic species. Applications in agriculture. Geographical Information System, GIS, is usually a set of computer tools and is a unique platform that allows one to work with multiple data that are tied to a spatially mapped location or area on Earth. This allows for multiple data of varied detail to be graphically depicted on a map and thus providing visual and other indicators to ease associated decision making. Advanced computer technology can now support provision of query-based information and allow for the rapid computer analysis for use at individual farms and across large territories. GIS tools and analytics can accurately depict the collection of data on crop acreage, production, crop health, disease and also maintain geodatabase of farmers. 222. 1740. One crop cutting experiment, CCE. In the absence of modern technology-based solutions, crop cutting experiments, CCEs, are used to estimate the yield of a crop. This is essentially a statistical survey method used to support crop insurance schemes that are area and yield based. To perform crop cutting experiment, the first step is to identify sample plots in the notified insurance unit area, district, taluka, village etc. Depending on the area, the number of CCEs to be undertaken can be large, resulting in high time and cost investments. The crop production estimates are obtained by taking the product of crop acreage and the corresponding crop yield. In many countries, crop yield estimation is based on field reports using conventional techniques for data collection. Satellite images are used where possible for identification of the sampling plots. Nevertheless, CCE methods are time-consuming and costly, prone to large errors due to incomplete ground observations, and often lead to poor crop yield and crop area estimations. Recent advancements in technology have made it possible to rely on high-resolution satellite data sets on periodic basis. Reliable and timely information on crop area is extracted very efficiently, which can be correlated with yield data. This will aid in more accurate crop production estimations, add transparency to the system and speed up the crop insurance processes. 2. Crop health monitoring. The crop condition information at early stages in the crop growing season is more important than acquiring the exact production after harvest time. Research and advanced technologies in the field of remote sensing, have enhanced the ability to detect and quantify physical and biological stresses that affect the productivity of agricultural crops. The district-wise crop health condition assessment is possible for major crops, viz., cotton, groundnut, paddy, wheat, potato, rapeseed, gram, tobacco, cumin, jova, etc., using vegetation index computed from multi-date atmospherically corrected high-resolution satellite data. The scientific basis to the assessment of the crop condition health assessment is on account of the determination of NIR, near-infrared, and red reflectance for a crop, primarily by the internal leaf cellular structure and chlorophyll content respectively. In principle, any damage to chlorophyll content due to pest, disease, nutrient stress, or delay in crop sowing manifests itself indirectly through an increase in red reflectance, lowering indices value. Further, these stresses can also lead to the destruction of leaf internal cellular structures resulting in lower NIR reflectance. Hence, crop vegetation indices values can also be used to detect and flag stressed crop. 3. Drones in agriculture technology has changed over time and agricultural drones are a good example of this. Today, agriculture is one of the major adopters of drones in management. Drones can be ground-based and aerial-based and are increasingly used for field analysis to monitor crop health, irrigation, pesticide management, planting, etc. Drones currently operate at 0.5-10 cm resolution and aerial drones, UAV, unmanned aerial vehicle, can fly close to the surface of the canopy of natural stands or crops. Drones can be used. 223. 1740. For conducting aerial surveys at regular interval to study the difference in land use, crop loss assessment, crop health imaging, and integrated GIS mapping. The uses of drones for gathering valuable data via a series of sensors, multispectral, thermal, and visual, for use in analytics, mapping and surveying of agricultural land. Near real-time disaster survey can be carried out using drones. The operators can enter the coordinates of the field to survey and select an altitude or ground resolution. When pesticide spraying is taken up using drones, water bodies on the field can be avoided if previously mapped. Depending on the sensors deployed on a drone, various data can be captured, such as plant health indices, plant counting, plant height measurement, canopy cover mapping, field water poisoning mapping, scouting reports, stockpile measuring, chlorophyll measurement, nitrogen content in the crops, drainage mapping, weed pressure mapping, and so on. 224.